we've been talking about air pollution, and there are ways to curb that pollution. And so there are certain control measures that we can put into place to make sure that pollutants are not as emitted as much as they would if these measures were not in place. And so, one thing that actually seems to work for sulfur dioxide is through emissions trading, or what we call cap and trade. And so, pretty much a plant is allowed to emit a certain amount of a pollutant, and they can either buy credits to allow it to emit more, or if they don't emit as much as they are actually allowed, they can sell their credits to another plant, and so it becomes a trade between industry. So they're capping the amount of emissions they're allowing out in the atmosphere, and their industry is trading between each other. So hence the name cap and trade. Here is a video that is in our links in the Google Doc if you want to learn more about cap and trade. So some other pollution control measures that we can put into place. So an electrostatic precipitator is actually trying to catch all of the particulate, not all of, but a bunch of particulate matter that would normally just go out into the atmosphere by giving these particles a negative charge right here. You can see through this blue line, which is a negatively charged metal grid, the particulates come up, get a negative charge, and then these positively charged collecting plates will actually pull those negatively charged particles over. So the emissions would leave with less particulate matter. I wouldn't say without, but less particulate matter. And the particulate matter would get caught here, and then usually they kind of bump them or something, and it causes the particulates to fall into a collection tray. And so this can actually remove a lot of particulate matter. So about 99% of the particulate matter from a plant can actually get removed from emission. And the problem with this, though, is that it uses a large amount of electricity. It's really ineffective at removing very fine particles, so that PM 2.5. And then it can also, well, it does produce this toxic dust that's collected that now we have to dispose of in some way. And not to mention, it's also really expensive to retrofit plants that already are working, and so they end up needing to be retrofitted with this kind of pollution control measure. So they can be very expensive. Another way to remove particulate matter is through something called a wet scrubber. And so what this does is it mists water or water vapor, so it actually puts out very, very fine droplets of water, and the water will actually trap the particulates, and the sulfur dioxide passes through a slurry of lime, which is calcium. I'm sorry, yeah, calcium oxide or limestone. And what this does is it neutralizes the sulfur dioxide. So it actually catches that as well. So before we were only catching particulate matter, and now this is actually catching some sulfur dioxide as well. And so this sludge gets collected and disposed of in a landfill, so it is somewhat toxic, but it does remove 98% of sulfur dioxide and particulate matter. Again, it's very expensive to install, especially if it's being retrofitted, and it's actually really expensive to maintain. Um, it is ineffective at removing hazardous um, fine and ultrafine particulates, just like the one before it, the PM 2.5 is not very effective for those size particulates. Another way that we can reduce our emissions is through burning low sulfur coal. And so here we burn in the, where we burn the most coal is actually coal that's a little bit higher in sulfur. It's called bituminous coal. But the low sulfur coal is called anthracite. It's a little bit more expensive and also more rare. You can also wash the coal of sulfur compounds with that lime and limestone, and that's where we call clean coal, where we wash the coal, although it never gets rid of all the sulfur, so there's no such thing as really clean coal. There's cleaner coal, where we actually liquefy or gasify the coal. And so by doing that, you end up having a more complete combustion, and therefore it burns a little cleaner. The fluidized bed combustion is actually blowing a stream of hot air into a boiler to burn a mixture of powdered coal and limestone. So again, trying to reduce that sulfur emission. And so here's a little commercial about clean coal. It's pretty funny if you want to watch it. It's in the link.